All right, kids. So we're going to talk about Stemplots now. So we're switching into our first dive into numerical data. This is quantitative data that we could take averages of, different than categorical. So when we talk about Stemplots, we'll first need some data. So here in our example, we have horsepower of cars reviewed by Consumer Reports. Now, when you have a data set like this, and this one's kind of long, what I would really suggest is that you enter the data in your calculator, which I'm going to show you an example of how to do that in the next example. Because if I go through and I'm trying to make a stem plot based on the data that's not in order, what I have to do is find a way to go through and keep track of the data as I go. When we make a stem plot, we will have a stem, which is usually going to be like past the ones place, so like the tens, so 70, 80, 90, even 100. We could put the stems over here. So the smallest values I see are in the 60s. So I might start with 6 over here, and then I'm looking for all the values that are 60s, and I got to kind of hunt and peck to get them all, and it's not the most efficient, right? So I see that I have some values there, and this is really helpful for what we'll do with stem plots eventually to be able to put these in order from least to greatest. So my smallest value I have here is 65. And so I'm going to put a 5 over here in the ones place. Ignore that. This is a problem with this pin on this thing. So 65, and then I have another 65. And then I have 68. Ooh, I have another 68 there. Two 68s. And then I have 69. And I think that's all the 60s. But that's the part of the problem with doing this while I'm looking at this big data set is it's easy to miss things, right? So I have two 68s, a 65, another 65, and a 69. And I think that's all the 60s. And then I go to the next value of 70s, and I'm trying to get all the 70s here. So I have 75, I have 70, 71, 78, 71 again. Okay, so 70. So I'm going to make my stem here, and then my leaves are these values. So I have 70 and 71 and 71 again. And notice that I'm trying to line these up in columns. And 271 and 75, right? And so we can see the frequency if I line these up well. I can see that there's one more in the 60s than in the 70s, for example. Now, I'm not going to take the time to go through this whole thing because I like putting them in order first. It makes it a lot more efficient. But this is how we're making a stem plot. And then somewhere, once we're done with all these values, we would have a key. And we would say something like, oh my gosh, this thing. Ignore that. 7/1 is 71 horsepower. Okay. Sorry for all this. Like I said, this pen on this board does not work very well. Anyway, we have it built for you in part because writing on here is not great. So you can see we went from least up to greatest. We can also start with the least and go down to the greatest. It really doesn't make a difference as long as we go in order. And everything's lined up really nicely. And we have our key down here, 6/5 is 65 horsepower, right? So this is building a stem plot. Now, what I can see here is frequency. We can see we only have one car in our sample that had something in the 140s. We have several times that we had 5 cars, 110s, 90s, and 70s and 60s. So those are some things that we can do with our stem plot. This is not all that interesting, but you can see each decade, going up by tens would have its own line, but that doesn't always happen. If we had a whole lot of cars that had 110 to 119 horsepower and it went really, really far, if we had that in a couple of places, we might choose to split the stems, which we're going to show you in the next example. Okay, so this time we have US presidents. Now, this is also a handout that we gave out in class. So we have all this data. You might want to pause it and actually enter the data in your calculator. I strongly recommend that you play along here because we have 2 sets of data. We have age at inauguration and the age at death. And you can see some presidents are still alive, so we don't have data on them, but we can see the age of inauguration and age of death. So what we're going to do is make a back-to-back stem plot because we have two pieces of data for each person, one involving their age at inauguration and one involving their age at death. And when we do a back-to-back stem plot, rather than having one line with the values there, and I think the youngest we have is in the 40s. So I might go, okay, I'm going to have 4 and then 5, 6. No one was inaugurated after their 70s, right? Ugh, that really is annoying. Sorry for that, kids. But we get there's no way around it. It's just awful. It's awful. Okay, so right, normally we would have like one variable, so we go in this way. But if we're going to have two, we may decide that we're going to have inauguration on this side and death on this side. And we're going to try to, I really wish I knew why it does this. It's so annoying. And I try not to write with this tool. I usually use a different one because of that. But we're going to try to build this stem plot in two directions at the same time, right? Because we have some people that were inaugurated in their 40s and died in their 40s. And so they're going to go in both directions. So if we were just going to put Garfield on here, for example, I might have a 9 going this way. So I read this to the left, 49. And if I put a 9 on this side, I read this to the right, 49. So age and inauguration is going to go this way. So I'm going to get rid of this stem plot, and I'm going to build it with a different tool because it's really driving me crazy. But before we do that, we're going to put the data in the calculator. So hopefully pause it if you haven't. Put the data in the calculator. Now the way we're going to do that is to hit stat, go to edit, and then under list 1, I'm going to put in the inauguration ages. Now I have all those here already to save time so you're not watching me type in numbers. But I have all their ages at inauguration on list 1, and then all the ages at death in list 2. And what I'm going to do is sort the data. You can see that I have, it goes down here to 48 right now. You can see all the way up to Pierce. But I'm going to sort the data so it's easier to look at, because if I have to hunt through here, this is no better than hunting through here, which is really not efficient. So I'm going to go to stat. And if you don't know how to do this, you need to take notes on this because we're going to do this often. Go down to sort A. So I go from the 40s up to the 70s. And I'm going to tell it, okay, I want to sort ascending. And I want my inauguration ages. So I'm going to use list 1. So I hit second and then number 1, and it'll give me list 1. If I want to sort the ages at death, I can do that also. I'm going to go to stat. I'm going to pick sort A. And then this time I'm going to tell it list 2, so second and then number 2, and it'll say done. Now when I go back to look at the lists, I'll edit the lists. Now they're in order, and this makes making a stem plot much faster. So I'm going to pull this off the screen so I can use it, and I'm going to freeze the screen and write on it so it doesn't keep jumping around. But here we will. Okay, so here's my little pen that will not do that. And again, I'm going to put 2 columns. And if I start here and I say, okay, well, we're going to have inauguration and death here. And I start and I'm like, all right, I want to put things in the 40s, 50s, 60s, 70s, 80s, and 90s are like the oldest presidents that we had. And so for inauguration, I have 42, 43, 46, 46, 47, 47, 48, 49, 49. Now that got pretty long, but when I get to the 50s, it gets even worse. Like there are so many presidents that were inaugurated in their 50s that when I start to write this stem out, I have, all right, 50, 50, 51, 51, 51, 52. Notice I'm still trying to keep these in columns so I can see frequency. 2, 4, 4, 4. And then I got to keep scrolling down here. There's another 4 and a bunch of 5s. And kids, I run out of room. And this happens sometimes, right? We have such a big data set, 46 people, but a lot of them were inaugurated in their 50s. And so this gets so long that we really can't display it very well. And part of our job as statisticians is to create a good data display, not just a data display. So this becomes so long that if I kept going, we're going to have way more elements. I'm out to the 36 presidents 35 presidents were 58 or less. So we take these out. We're at a lot. There's a lot of presidents there, a lot of data points. We're going to split it. So what we would do if we're going to split the stems is we're going to start in a similar way. And it doesn't matter. Again, we can go highest to lowest or lowest to highest. Sorry for that. Those bars are not great. I could probably do a better job if I just used a different tool. But all right. So we got 40s. But this time I'm going to go, all right, 40 to 44, and then 45 to 49. Because if I go 40, 41, 42, 43, or 44, that's 5 numbers, right? From 0 to 4 is 5 digits. And then all the next values are going to be 45 to 49. That's also 5 digits. And then I'd have 5, and then a little asterisk, and 6, and a little asterisk, and so on. And then we can go and list these out. Okay, so if I start doing that, for example, and I'm just going to jump to something that's a little bit shorter, so I'm not taking too long to do this. But if I'm doing the 60s, I would have 60, then 61, then 61, 62, 64, 64. And when I get to 65, I just come down here. Here's 65, here's 68, and 69. So we see lower 60s and upper 60s, for example. Okay. And when we do that, here's a completed example. So we have 40s, lower 40s, upper 40s, lower 50s, upper 50s. And if I look at this value that's right here is an age that's 57. And this value that's right here is 68. And this value here is 70. Okay, if we're reading that way. And if I go over here, here's 63, 67, 79, etc. Okay, and we have a key here, 3/4 going this way is 43, and */6 is 46 because we included that here. You can see that. Okay, so we have a key always. Notice there's a couple things that I really want you to pay attention to. There are no commas, and there are no decimal places. So we don't put commas in our stem plot. You want to look like you've actually been in a stat class before. And we don't put decimal places in a stem plot. We would round those values to the next nearest number, or in some weird cases, sometimes we have things like pH. And so if I had a data set with pH, I might, look at this data set. I might have like 4, 5, 6, 7, and then some numbers, 3, 5, 7, 8, 1, 2, 3, 6, 7, 9, so on. And then I would have my key, and 5/1 is 5.1 pH, right? So we put the decimal places out here, or the tenths places. And if I had a pH that was like 5.05, I just rounded to 5.1. But these values are the tenths place, not the ones place. And we have to have a key to know that. Otherwise, if we would have gone back to the horsepower problem, and we had a horsepower of like 88.7 horsepower, we're just going to round that to 89 before we start building our stem plot. We would not put decimal places in the stems, or in the leaves. All right, kids. So there is stem plots. Use stem plots for small to fairly moderate sizes of data. Try to use graph paper or make sure that our numbers line up. Really important that we have nice columns. I pointed that out earlier, not jamming things together. It makes it hard to see frequency if numbers that take up 3 spaces also take up as many as 4, or here we have 5 that are going out the same length, right? We want to be able to line them up so we can see frequency. That's really important for what we're going to do. We also want them in ascending order so that when we use these later and are trying to find the middle of the data set and we're counting, we know that we went up the number line in the right way so that we can find the median, etc. That's not for a while, but we're going to do that eventually. So it really helps if we put them in order. And that's it.